Dear colleagues, thank you for inviting me on this wonderful conference. I hope the university, Government College University, Faisalamabad arrange such kind of the conferences and in the next year also. So first of all, I would like to introduce myself. My name is Dr. Mohammad Ayub, and currently I am working as a lecturer in Department of Chemistry, University of Sahiwal, and also running the higher education project on NRPU. And current presentation is also part of my research project. So the topic is a response of its methodology for optimum extraction of essential oil from Eucalyptus globulus leaves by superheated steam extraction. The main objective of the current study was to develop a methodology for optimum extraction of essential oil from Eucalyptus globulus leaf by using superheated steam distillation. So, for the optimization response of this methodology, the standard composite resin was used to study the effect of extraction conditions like temperature, time, and superheated steam flow rate on essential oil heat. And the results showed at 138.5 degrees centigrade temperature, 50 minutes time, and 60 ml per minute flow rate gives an excellent yield of 1.749%. That was quite higher than conventional extraction technique that show 0.65% and 0.59% at 180 minute extraction time. So overall, this technique is quite well. They give a three times higher essential oil yield as compared to hydro steam distillation in shorter extraction time. So GCMS was used to study the chemical composition that show one detail. Senior was a major chemical component. Alpha-thiogen, beta-thymine, 4-tretinool, and peptidone were the main compound that varied with the extraction techniques. So what are the essential oils? Most of you guys already know about what is essential oil. These are the secondary metabolites of aromatic plants. They have strong aroma and also known as ethereal oils and volatile oils that are present in granule trichomes, like structures that you can see in this figure. These are the granule trichomes in which the essential oils are synthesized and stored. So whenever we capture these granule trichomes, the essential oil come out from these glands and can be extracted. So there are different methods that use for their extraction, like by applying the pressure to the raw material, we can extract the essential oil, and also we can heat them, provide the heat like in the form of hydro distillation, steam distillation, and we can capture these granules and essential can come out from the plant material. So there are different sources from which we can extract essential oil, like from the leaves and from the peel, from flowers, from stems, dry plant woods, woody material, and also from the oleoresins and oleogum resins, also from the animal source like musk deer and amber whale are the resource of the essential oil. So essential oils are basically composed of monoterpene units that combine together and form sesquiterpene, diterpene, triterpenes, carotenoids, and steroids. Overall, essential oils have a huge application and demand due to their application in flavor industry, in care industry, health industry, and other industries like pesticides, motor industry, paper industry, rubber industry, plastic industry, textile industry. So due to their huge application, they have huge demand in the market. Different methods are used for extraction of essential oil, like from hydro, steam distillation. These are traditional methods. Superheated steam extraction, super subcritical water extraction, and superheated steam extraction. So this is a classical setup of hydro and steam distillation. See, most of you guys already know about it, so I will not go in much detail about it. So supercritical fluid is also advanced type of chromatography extraction technique in which supercritical fluid is used for the extraction of essential oil. and that has some advantages like they work on the low temperature, environment friendly, and solvent free extraction technique. We will not talk about both can be extracted from this technique, but they also have disadvantages like high maintenance cost, equipment cost, and the extraction of other compounds along with essential oils like fatty acids, fat, coloring materials, resins, and wax. Next is a superheated steam extraction. And superheated steam, that is one of the emerging techniques in which we use a superheated steam that has temperature from 100 to 50 degrees centigrade. Uh, Due to the very high temperature, it's a rapid method of extraction. It give high yield, low chance of oxidation of the product, and high extraction efficiency. Previously, it is used for the extraction of essential from phosphine, acetaldehyde of resins, black pepper, thyme, and some other plant materials. Globulus is a plant that is extracted essential oil that is extracted from Eucalyptus globulus plant. It is native from Australia, and they have a huge biological applications like in antioxidant activity, antimicrobial activity, anti-diabetic, antiviral, and antifungal etc. Secondly, they have due to the high demand, they are have excellent application in different medicinal industries also. So, in this research work, we try to focus on extraction of essential oil by superheated restoration, as this technique was not used before for the extraction of essential oil from Eucalyptus globulus. So, we try to extract the essential oil from Eucalyptus globulus leaf and observed that it was quite interestingly show excellent result as compared to conventional techniques. So plant materials was collected from vicinity of University of Sahiwal, dried them, and after grind them into 60 mesh size and used for the further extraction through hydro steam and superheated steam extraction, and chemical composition was determined by gas chromatography. So, responsible methodology, central composite design was used for optimal extraction of essential oil, and three levels of extraction at 120, low, middle, and high are used for the temperature 120, 140, and 160 conditions was used for the time 30, 40, 50 minutes, and the flow rate of 60, 80, and 100 was used. So by using the software, say 18 design experimental design were developed, and after that the yield was determined through superheated seam extraction. So here these are the results of these extraction techniques. As you can see, at 160 50 minute and 60 flow rate, 1.6% yields are obtained. So highest yield was obtained at 140 degree centigrade temperature 40 minutes and 60 flow rate. It was 1.73, and the lowest yield was obtained at 60 degree centigrade temperature 50-minute extraction time and 100-hour flow rate, that is 1.52. Summary fit shows that the quadratic design was the best for the optimization of essential oil, and the regression analysis model equation shows that the positive signs in these equations shows that they have a positive effect on the yield. Like if we talk about the second polynomial equation represented above, where y is the yield, a is the time, A is the temperature, B is the time, and C is the flow rate. A square, B square, C square are quadratic term. A, B, A, C, and B, C are the interaction terms. So a positive sign of ABC shows that essential oil yield increases with increasing the temperature, time, and flow rate, and quadratic components of A square, B square, which were both negative, show that the superheated steam extraction during duration and like in time and the temperature increases and the yield is fall decreases. Consequently, a positive value of a quadratic term C square indicated the exponential relationship means that even at a reduced flow rate, the essential oil give ultimately increase the yield. Next is the NOVA table that show a significant results of our significant value that show that our experiment is quite good. So, if you talk about the credibility of the analysis, it shows a R square value 0.98%. That is quite good one, and adjusted value 0.95%, and predicted value 0.78%. So, if we talk about the effect of supersteam on different factors, this is a 2D three-dimensional uh, uh, graph in which you can see the effect of temperature here and the time this one. So as we increase the time, the yield was increased, and after a certain time the yield was decreased. That might be due to the high temperature, and after 140 degrees centigrade the yield was decreased. That might be due to the decomposition of some of the compound. Similarly, if you talk about the time, initially the yield was low, but with the passage of the yield was quite little bit increase, and after some time it is decreased. Similar type of the effect was observed with the flow rate and the temperature. In flow rate, the low flow rate show quite higher essential yield, but as we increase the steam flow rate, there is a minor decrease in the yield. Uh, Similarly, if we talk about the time, the yield was gradually increased up to the certain point, and after that, the yield was decreased. So, the experimental and predicted values of percentage of globulus essential oil under optimized conditions shows that the predicted value by the software was 138.45 times 50 and 60 the flow rate show, and that the result will be 1.756%, and the experimental value shows that it was 1.749%. That is very close to the predicted values, and they show the credibility of our results and experimental results. So we compare these results with the optimum condition results compared with hydrogen steam distillation that showed the yield was gradually increased and a three-time higher yield was obtained as compared to steam and super steam. So this technique is quite good for extraction of essential oil. The chemical composition was studied by GCMS, and they showed overall 24 compounds are present in the essential oil, with 1,8 as a major compound, followed by gamma, alanine, peptidone, beta thymine, and alpha-toluene. So these are the results of the GCMS. And finally, we go to the conclusion session. The study of super distillation extraction was utilized to extract the essential oil from the Eucalyptus globulus leaves. The investigation focused on assess on the impact of extraction condition, including flow rate, time, and extraction temperature on essential oil yield using small cell methodology. A regression model was developed and validated on the basis of experimental design to optimize external condition, resulting in an optimum yield of 1.73% achieved at the condition of 60 ml per minute flow rate, 140 degree centigrade temperature, and 40-minute iron. The optimized yield was quite higher than hydrogen simulation. The model validation was performed to check the desirability of the model that shows 0.962 within a 95% prediction range, and the results show at 138 degree centigrade temperature, 60 minute flow rate, and 50-minute. A response of 1.749% was obtained, that was close to the predicted value of the software. The higher percentage yield of oxygen monoterpene found in essential oil extracted by all three methods, particularly 1,8-NUL, are the principal component of essential oil. So overall, this super steam extraction is a quite good technique, and they show a quite higher essential oil yield, and they can be used in nutraceutical additives and offering variable applications in commercial use of essential oil. The application of response will not only optimize extraction condition process but also provides insight into the underlying the mechanism and interaction affecting the extraction of essential oil. This knowledge can be used to enhance the efficiency and investigate the possibility of other material for essential oil production. So, thank you for today's presentation.